It's incredibly dangerous to have a skateboard out on stage. I see these people raising a bar out here. I'm really excited. This is certainly one of the ones that I've been looking forward to. You guys are all well acquainted with each other, right? It's still a relatively small research at this point. Let's go down from the end. Avi, if you can start, introduce yourself and tell us a little about the company.
Sure.
My name is Reichental. I'm the CEO of 3D Systems for the last almost decade. And 3D Systems invented 3D printing nearly 30 years ago, March 9th, 1983.
So you just had a birthday then?
We did. It actually took the inventor, Chuck Wall, and his wife, and we celebrated at 8:39 p.m. Pacific Standard Time. A week ago, we celebrated the birth of the first ever 3D printed part.
Big 3D printed cake, I assume?
Absolutely. And tasty.
How
is the food, guys?
How is the food, guys?
We should talk about
We'll be talking about that a little bit more. You're the icing guy.
So, I've been using 3D printing since 1995.
Oh, can we get a hot sound tonight? It's like how loud can you speak?
So,
there we go.
Okay, good. So, I've been involved in 3D printing since 1980 or so, using it mostly for robotics, but since then we've been working on quite a few different areas of advancing the technology into new domains, like food printing, bioprinting, printing electronics, and those kinds of things.
And Max. Yeah, right. Some bugs to work out at the top of the show. We're new to the whole technology thing. So
Formlabs. I'm Lobovsky. I'm the co-founder of Formlabs, and Formlabs is bringing high-resolution 3D printing to the desktop. Our first product, Formlabs,
we have sort of a big optimistic title for the panel, 3D printing goes mainstream. I feel like obviously we're not quite there, but certainly a lot has happened over the past year or two. Avi, I'd really actually like to start with you, and usually when I do these discussions of 3D printing, I don't like to go too much into the history, but you've certainly got a better perspective on that than anybody. I'm kind of wondering what the original impetus for the development of rapid prototyping and 3D printing was.
When I look at 3D printing, I look at it basically in three categories. One is the business-to-business aspect, and there a great deal has been accomplished, starting with airframes flying with printed parts for the last decade, implants, teeth, in the hearing aids. A famous company here in the Bay Area, Invisalign, built its entire business on 3D printing, and they today print on a daily basis, day in and day out, some 65,000 unique and distinct, basically aligners on a daily basis. So it has scaled, and of course, if you read the media, Jeffrey Engel is now committed to using 3D printing technology to put it on board the next generation jet engine. And that's all about fuel efficiency and sustainability, and he's targeting something like nearly 25 to 30% fuel efficiency gains as a result of printing something that's really complex and then casting it. And so in industrial applications, it has scaled and it has become cost effective, and there are nearly something like 150 different materials that are available between all the players that include metals, waxes, plastics, composites, rubber-like materials. The second category is for home use, and for home use up until now, for the do-it-yourself and the hobbyists, what we've seen primarily is the democratization of the fused deposition type modeling systems. By and large, and now we see some of Max's work, that's coming out, and it has been, the democratization is happening. The prices are going down. The material availability, the printability, the fidelity, the UX has a long way to go. We're spending more time talking about how we make the printers work as opposed to what can my printer do for me. So the big opportunity here, improvement in UX, plug and play, fidelity, and more materials. And then there is the part that we talked about last week at MIT, which is, where is the future? What about 4D and 5D, and where is it all headed in the future? So that's kind of my perspective. Very exciting. It's going to change everything in the next 5 to 10 years. And I think that we live in a very exciting period in human history.
As you mentioned, we're already talking about 4D. MIT showed that off at a TED Talk not too long ago. The idea before to mention being time, so this is essentially something you could stick in water, I think was the first example they had, or add any sort of external stimulation to, and it'll kind of fold out and create a new shape. I'm wondering right now, as these things are becoming more and more mainstream, as we're moving onto desktops, the question everybody's asking me is, are these toys at this point? Are people buying, spending $2,000 on a toy, or are home 3D printers already something more than that?
Well, I think Avi put it in a really good context that this is actually a 30-year-old technology that's been used in many industries to a lot of great things. It's actually pretty well known what it can do well. But I think what you're referring to is just recently people have figured out that you can bring these tools to the desktop and get them to machines that are less than a few $1,000s. And I think the big breakthrough was just the idea that we could take these machines that were tens of thousands, hundreds of thousands of dollars and bring them to the desktop. As an early promoter of that idea, and I actually worked in Hans Lab on some really open source 3D printers. And I think initially that was an important step, but now we have to take it further. It's not just the idea is not good enough. We have to take this pretty complicated, expensive technology and get all of it packed into a small machine that's affordable and that can really work well to be useful on the desktop. There's kind of a big step from a machine that sort of demonstrates the process and that's fun to watch and one that can actually be used reliably and produce really high quality output. So that's what we're focused on, being the first people to do that in a desktop machine.
And just to some degree, you're sort of waiting for people. It's a platform, right? I mean, you're waiting to see what people can develop, what sort of useful applications people can create out there. I'll be able to
it is and it isn't, because I think that in every evolution, we have to look at the early adopters versus the mainstream. And what's happening here is we have this incredible convergence of enabling technologies, cloud computing, mobile devices, incredibly accurate and cheap sensors, robotic devices which influence the cost and the ability to democratize. The fact that you have this incredible serendipitous convergence of all these technologies allows us to do things that we didn't even think were possible 5 years ago. Not because 3D printing in and of itself couldn't do it, but all the enabling infrastructure from this convergence didn't exist. So you begin to think about what can I do with a 3D printer for an 8-year-old? How can I begin to unlock young kids' creativity so that they could have more skills today? That's tangible in the here and now. What can I do to launch completely new business models? Whether it's on the Internet of Things, or whether it's to empower garage entrepreneurs to have the same access to the more expensive printers via cloud printing, so that they could do things like metal printing or launch incredible guitars. All that is tangible in the here and now, and the technology basically is democratizing access. There is more to do in materials. There is more to do, to Mike's point, on affordability of really high fidelity, high functionality on the desktop. But it's happening and it's inevitable. The train left the station. But with what you have today, everything changes. How you learn, how you create, how you make, how you market, how you change your retail experience. What does it mean to the established brand? It's all going to change in the next 5 to 10 years, and we're fortunate, all of us, to tap into it and figure out, how do we insightfully rearrange the world as we know it.
I think it's very much like sitting here, imagine ourselves sitting here in the 70s, trying to imagine what the computer revolution is going to be. How the transition from mainframe to desktop is going to change everything. So I think we could easily have imagined that computers would be used to do payroll, to do military calculations, but nobody in the 70s could imagine the internet, let alone social networking, e-commerce, and so forth. So this is, I think, the stage we're at. We are gradually transitioning from mainframe 3D printers to desktop 3D printers. That's pretty obvious. That's happened already in the last couple of years. The first killer app, so to speak, seems to be kind of toys and things like that, like you mentioned. But that was true also for computers. The first applications of desktop computers was gaming. And that gaming was very important. It's not that only the gaming industry also developed talent. Later on went to invent all the rest of the stuff. And this is, I think, what's happening now. This technology is becoming pervasive. Literally, you stop people on the street, most likely have heard about 3D printing than not. That was not true just a couple of years ago. And I think that we are just on the cusp of people going beyond the technology itself to actually invent truly new business models, new applications that go beyond just using the machine to make something. And that's what we're waiting for.
Yeah, I feel like in a way the project that you've been working on at Cornell sort of serves as a transition point between these industrial 3D printers and these at-home ones that we're seeing. And I'd love if you could sort of take us through the role that the open source community played, the role that education played in making that transition.
So I think the open source community, I think, played an important role in the kind of early 2000s of this technology. When at that point, I was very excited about technology, but also frustrated with the fact that most people did not know about it, and especially it was not accessible to because of its price and because of its relatively narrow markets. It was not accessible to most people. It was difficult to hack. It was difficult to export new materials, and for a number of different reasons: technology development, new materials, internet, all these different things. Everything came together around the mid-2000s, where a couple of these open source systems came along. We launched the Fab at Home project back in 2006, completely commercial-free open source system. There was also RepRap launched at the same time, more or less. And the goal of those systems, they were both university-driven, was to make a system that is very, very simple, lower in quality, comparable to commercial systems, but open and hackable. And again, the idea was not necessarily to make things with it, but to just allow a lot more people access to the technology and remove the barrier of entry into this technology. By now, I think elements from Fab at Home and from RepRap have wormed their way into many of the dozens of open source systems today.
These are certainly a lot of the ones we're seeing on the market. They're very much the basis for these models. Wondering, you as a student, you experimented with these things. At what point did you decide that this is something you want to get involved in? I mean, obviously, right now, and this is something I think I really sort of discovered at CES was just how many 3D printers there are commercially available. I think I counted somewhere in the neighborhood of 25 companies around the world that might actually be low right now. And I'm wondering, you as a startup, as a crowdfunded startup, why did you want to jump into that?
Well, I actually started working on, as I mentioned, in Hud's lab in about 2008 on the Fab at Home project. So that's kind of where I first saw that something like this might be possible. And there was actually some people trying to sort of do a commercial version of that open source machine. And so working with them and trying to understand what they needed, their needs as opposed to what we were interested in as running this open source project really sort of started to help me understand that you need to focus on, there's kind of difference in focus. And I watched some of the early 3D printing companies come out, MakerBot and a whole host of others. And at first, honestly, I was a little disappointed. I thought I missed the boat, and these guys have a good start. But I realized then that there's just so much more you need to do than just build a machine that does 3D printing. You need to make it work out of the box, you need to make it work reliably. You need to make it made beautiful parts that people actually want to use for something. And that hasn't been done. And when we realize that, and we realize that we can do that, it's no brainer to get started.
I wonder if this